I'm Jalisha, Assistant Professor, Department of Mathematics, St. Joseph's College of Arts and Science for Women, Hosur. Today we are going to see the topic equivalent formulas in discrete mathematics. Let's move into the topic. Here are some basic equivalence formulas which we are going to apply to get the other equivalence formulas. So before moving into those topic, let's see how these equivalence formulas arrived and how we proved those equivalent formulas. So here in these equivalents, T denotes the compound proportion that is always true and F denotes the compound proportion that is always false. So what it says, if we are considering the truth value T as the variable, then it will consider only the true values if it is having two rows. Minimum we should have two rows. Or else, if suppose 4 row means all the values will be false. And similarly, for F, all the values will be considered as false. So this is the condition for T and F is considered in the place of proportion variables. Okay. Now the first formula is P cap T is equivalent to P, and in the same the second one is P cap F is equivalent to P. These two formulas are called as identity laws. Let's see how this comes true. So as I have explained already in my previous video that the number of rows will be defined based on the term 2 power n. Here n represent how many proportion variables we are considering in that formula. Now in the first formula we are having only one variable p and t is the common variable. So the specific variable here we have considering is p. So how many rows we need to fix here? N is 1, only one variable. So 2 power 1 is equal to 2 rows we need to fix. So let's go with the truth table P, and it is going to be combined with T. What is the operator applied in the first identity law is cap. So we can give P cap T here. So this answer we need to get. So P means only 2 rows. So first possibility should be true and second should be false. And the second one is T. It is a common variable. T means it should assign all the row values as true. Now we need to check P cap T value. The meaning of cap is both the values are true means answer will be true. If not, here only one value is true. So you'll get the answer here as false. So actually in the identity law, what we need to prove P cap T is equivalent to P. What is the definition for equivalence? Either the comparing sides. One side value of the equivalence is P, the other side value of the equivalence is P cap T. See here, left hand side is P cap T and the right hand side is P. So those two values should be equal. If so, we can say both are equivalent to each other. Here we got both are equal. P value and P cap T, both the values are equal. So we can say P cap T is equivalent to P. In the same way, we can prove P cap F is equivalent to P. Here P value, as usual, only one specific proportion variable and F is the common variable. So one variable means how many rows we need to give? 2 power 1 equal to 2 rows. So we need to find the value of P cup F. F means it assigns both the values as false. Cup means what is the definition? Any one value is true means we can assign the value as true, otherwise false. So based on that, we need to get the value of P cup F and check the answer with P. If both are same means we can say that as equivalent. So by this proof, we get the identity loss. The next formula is domination loss. So here see, here the proportion variable is P, whereas the common variable is T. So P cup T means it will give the answer as T. So here T is the dominant. P cap F, you will get the answer as false. Here F is the dominance. So we can say these two formulas as dominance law. Now let's see how we are proving that value. What is the thing given here? P cup T. So only one variable P is here. So two rows P, and it is compared with, in the domination law, it is compared with true. So T, and we need to get the final value of P cup T. So let's put the value for P. True, false. This is the common value. So all the values will be true. Now cup T. Cup means P, this two columns we are going to join using the cup operator. For cup, the definition is any one value is true means answer will be true. So first row both are true. So true assigned. Next is only one is true. Again true assigned. So now you check this value. P cup T and T value are equivalent. So hence in the domination law, first line we have given P cup T is equivalent to T. Likewise for F, if you are assigning two values as F and cap is applied between P and F, we'll get the answer as equivalent to F. So these two formulas are called as domination laws. Next is idempotent law. So next one is idempotent law. In that first we need to show P cup P is equal to F. So only one variable but two times we need to give its answer. Let's see. So only one variable, so it is true, false. The same way only we will be able to give, because if we change the order, so for this P, if true is given and the second P, if for here true is given, and instead of change, if you are giving false here means it represents that the second column is the negation of P. So first row P, what type of variables? First is true assigned and the second is false means in the same format only we have to assign the value for the next column P also. Now our aim is to prove P cap P value. So P cap P, its answer is, cap means both are true means true. So in the first row both values are true. So answer will be true. But in the second both are false but cap consider only true. So you'll get true false. So now check the answer. True false. Both are P. So anyone we can combine. True false. So P cap P is equivalent to P cap, sorry, P. Likewise, we can prove P cup P also. That is again equivalent to P. So this formula is called as idempotent law. Next is for double negation law. So for this we no need to prove. We all know in general mathematics minus into minus will be a plus thing. So here negation means two times. Opposite of opposite will become the normal one. So negation of negation P will be equivalent to P, and this law is called as double negation law. And the next formula is given for commutative law. In algebra we all know commutative means Algebra means we'll apply either plus or multiplication, that is product between the two elements. Commutative means if the order of the element change, that is the first element is placed in second and second in first, even then the answer will be same. That formula is called as idempotent law. So here instead of plus or dot we are going to apply cap or cup. So we need to check the value of P cup Q and Q cup P. If these two values are same in a truth table, then we can say both are equivalent. So before that, we should know what is the assigned value of P and Q. How many different variables are here? P, Q, 2 are there. So 2 power 2, 4 rows we need to give. So the first value is 2 true, 2 false. Next is alternate, one true, one false, the other one is true, the other one is false. Now P cup Q. Cup means any one is true means true. See here in the first both are true, so answer will be true. Second row, first one is true, so answer will be true. In the third, here it is true, so the answer will be true. And here both are false, so the answer will be false. And the next you check here first both Q to P again anyhow from Q or P or P or Q. If it is conditional means the order will change, but here we are applying only cup. So cup definition is anyone is true means true. So again we'll get the same answer, true, true, true and false. So compare these two values, both are same. Hence we can say P cup Q is equivalent to Q cup P. Both are equivalent. So this likewise we can prove it for cap, and this formula is called as commutative law. And next we have given here associative law. In general maths or in algebra we know for associative three elements we have to consider P, Q, R. So here also three variables we have considered. But the thing is same operation. If cup is applied means cup only should be taken and cap means cap only should be applied there. And the associative laws difference is for the three elements in the left hand side first two are paired means in the right hand side the next two will be paired. Okay, so if the pairing is changed even then their truth table will be same, truth table values will be same. So we are saying P cup Q cup R is equivalent to P cup Q cup R. Likewise for cap. Next formula is distributive law. For distributive law, two operators we need to have. So here first line you see, outer line we are applying cup and the inner bracket we are having cap. So how we can express this? Cup P cup is applied with Q and R. So can we say explain this? P cup Q is in first bracket. Next cap, again P cup, it is paired with R. Likewise, the second formula. What is De Morgan's law? If negation is applied in common, then in the equivalent side of other will takes the negation inside. Negation value is applied inside the bracket means the cap will be changed into cup. So negation P, cup, negation Q. Likewise, in the second one, negation P, cap, negation Q, it will be frame. So these two formulas are called as De Morgan's law. All these terms can be proved using the truth table. What about the next formula? It is absorption law. Here see two operators we have applied, but in the bracket of the two elements, any one of the element is present in outside, then that most dominant value will be the answer. Here, how many times the term P is repeated? 2, whereas Q comes 1 time. So here, which is the dominant? P. Okay, one in out and other inside the bracket. So your answer will be P. Likewise, cup and cap is changed also, the same answer will get. And that law is called as absorption law. And the last one is negation law. That is, a term with its negation is applied, but the operators one time for cup and the other time for cap. So the formulas P cup negation P, if you are noting the value, means it gives only the tautology true answer. And if cap is applied between P and negation P, it gives only the contradiction value, that is false. This formula is called as negation law. And here are few more logical equivalent formulas. So all those formulas we are going to use in the next upcoming video for solving the equivalent formulas. So just go through with it. All these formulas we have derived using the truth table. We have proven using the truth table. Thank you all.